Here in this section, we have applied optimization. Solving applied optimization problems. Here we have steps. Step 1, read the problem. So here on this part, reading the problem until you understand it. We have to see what is given, what is unknown quantity to be optimized. Step 2, draw a picture. So label any part that may be important to the problem. Step 3, introduce variables, and that means we have to list every relation in the picture and in the problem as an equation or algebraic expression, and identify the unknown variable. Step 4, write an equation for the unknown quantity. If you can express the unknown as a function of single variable or in two equations into unknowns. Step 5, test the critical points and endpoints in the domain of unknown. So in this case, use what you know about the shape of the function's graph. Use the first and second derivatives to identify and classify the function's critical points. Examples: a rectangle is constructed with its base on the x-axis and two of its vertices on the parabola y equal to 169 minus x squared. What are the dimensions of the rectangle with a maximum area? What is the area? Here we have a picture of the problem. The rectangle that is to be maximized has its base on the x-axis and its two upper vertices on the parabola y equal to 169 minus x squared. So here is base of our rectangle, and we're trying to maximize this rectangle. So the point is that we have to find area, and area is equal to our base. Here we have x, so that is x, meaning that we have 2x. Here is y, so 2x times y, that is area. So area is equal to, we have y is equal to 169 minus x squared. So use that one here on this part. So we have 2 times x times y, which is 169 minus x squared. So a is equal to 2x times 169, that is 338 times x minus 2x cubed. Now finding the first derivative. So dA over dx, that is equal to 338 minus, we have 3 times 2, so that is 6. X power is 3 minus 1, so that is 2. Set the first derivative equal to 0 and solve for x. So we have positive value of x. X is equal to 13 times square root of 3 divided by 3. So here is our x, and then later we have to multiply by 2 to have 2x for what we had here on this part for base. Now finding y. So y is equal to 169 minus x squared. So that is equal to 169 minus 13 times square root of 3 divided by 3. squared. And that's equal to 338 divided by 3. And now finding what we had for base, that is 2 times x. We have the answer for x, so we only need to multiply by 2. So here we have 2x, 2 times 13 square root of 3 divided by 3. I'm rounding to 2 decimal place, and that is 15.01. So here on the spot that we had for y was 338 divided by 3. I did the same thing and rounded to 2 decimal place. So what we have for y is 112.67. Now that we have 2x and y, we can find the area of the maximum rectangle. We rounded these two numbers to 2 decimal places. So area is equal to 2 times x times y. And that is equal to 2 times x is 13 times square root of 3 divided by 3. And y is 338 divided by 3. Rounding to 2 decimal place, the answer is 1691.25 units squared. What are the dimensions of the lightest open top right circular cylindrical can that will hold the volume of 64 centimeter cube? The lightest can will be the one made from the least material. So the lightest can is the one with the smallest surface area. They're given by the sides and bottom of the can. Here we have the formula for surface area, which is S equal to 2 pi times R times H plus pi R squared. So R is radius and H is height. And in this case, R is greater than 0, so we don't have negative number for radius that is positive. So what we have here in this formula, we have R and H. I want to remove H and have this formula in terms of R, which is our radius. So I will use V equal to pi R squared times H and solve that one for H, and then use that here on this part. So that way we can remove H. So using V equal to pi R squared times H, solving for H, what we have here on this part, volume is given, volume is 64. So solving for H here, we have V is 64 equal to pi R squared times H. So H is equal to 64 divided by pi R squared. Now substitute H. Here in this formula we have S equal to 2 pi RH plus pi R squared. So this is equal to 2 pi R times H is 64 divided by pi R squared plus pi R squared. And this is equal to 2 times 64, we have 128. So pi divided by pi and R divided by R squared, here in denominator we have R plus pi R squared. Now minimize the value of S. So here we have to find first derivative of S. So ds divided by dr, that is equal to negative 128 divided by R squared plus 2 pi R. Now set ds over dr equal to 0 and solve for R. So here we have negative 128 over R squared plus 2 pi r equal to 0. Multiplied by r squared, so here we have negative 128 plus 2 pi r cubed equal to 0. So we have 2 pi r cubed equal to 128. Then r cubed is equal to 128 divided by 2 pi. So r cubed is 64 divided by pi. And r is 4 divided by cube roots of pi. Next step, substitute r into the expression for height, which is h equal to 64 divided by pi r squared, and then simplify. So r is 4 divided by cube roots of pi. So what we have, h is equal to 64 divided by pi times 4 divided by cube roots of pi squared. And simplify, and our final answer for h is equal to 4 divided by cube roots of pi. Therefore, the lightest open-top can that will hold a volume of 64 centimeter cube has a radius of 4 divided by cube roots of pi centimeter and a height of 4 divided by cube roots of pi centimeter. Find the dimensions and volume of the right circular cylinder of maximum volume inscribed in the sphere with radius 25 centimeter. The volume of a right circular cylinder with base, radius r, and height h is v equal to pi r squared times h. As you can see here in this diagram, the sphere radius is g, the cylinder radius r. So here we have radius. And the cylinder height is h. So this part is h, and what we have here for this one, that is h divided by 2. So what we have, the relation between all these three, r, g, and h divided by 2, we can use Pythagorean theorem. So here we have right triangle, and Pythagorean theorem, we have this side r squared plus this side is h over 2 squared equal to g squared. So based on what we have here for volume, pi r squared times h, and what we have here on this part, I can isolate r squared. So r squared is equal to g squared minus h divided by 2 squared, and then use r squared here on this part. So here what we have for volume is equal to pi r squared. Use that one, which is g squared minus h squared divided by 2 squared. So it's pi times g squared minus h squared divided by 4 times h. And that is equal to pi times here h times g squared minus h times h squared. So that is h cubed divided by 4. So this is the function that we want to maximize. Now take the derivative dv divided by dh, that is equal to pi times g squared minus pi times, we have 3h squared divided by 4. Now dv divided by dh equal to 0 and solve. So pi g squared minus pi 3h squared divided by 4 equal to 0. Pi g squared equal to pi 3h squared divided by 4. Isolate g squared, that is equal to 3h squared divided by 4. And then use this one to find h squared, that is equal to 4g squared divided by 3. And then using square root on both sides, we have h equal to 2g divided by square root of 3. Now substitute the given value of g into h. So a sphere with radius 25 centimeters, so g is 25, and h is equal to 2g divided by square root of 3. So h is equal to 2 times 25 divided by square root of 3. Running to 2 decimal places, the answer is 28.87 centimeters. Next step, here we have r squared plus h divided by 2 square equal to g squared. Solve for r, and r is equal to square root of g squared minus h squared divided by 4. And now substitute what we have for g and h here on the spot to find r. So g is 25, and h we rounded to 2 decimal place, and that was 28.87. So the answer for r rounding to 2 decimal places is 20.41 centimeters. Now here we have same procedure to find radius. So solve r squared plus h divided by 2 squared equal to g squared. For h is equal to 2 times square root of g squared minus r squared. And then use this one, this h, substitute into the original formula for volume. So volume is equal to pi r squared times h. So volume is equal to pi r squared times square root of g squared minus r squared. Next step, take the derivative with respect to r. So dv divided by r, that is equal to 4 pi r times square root of g squared minus r squared minus 2 pi r cubed divided by square root of g squared minus r squared. The next step, set dv over dr equal to 0. And solve for r. So here we have dv over dr equal to 0. So 4 pi r times square root of g squared minus r squared is equal to 2 pi r cubed divided by square root of g squared minus r squared. So solving for r, here I have all steps. So we have 2 pi r cubed, here denominator is 1, so 2 pi r cubed times 1 equal to what we have here, multiplied by this one, this square root. So that means here we have 2 pi r cubed equal to 4 pi r times g squared minus r squared. Because here we have square root, and here again I have square root, so that means multiplying these two, the answer for that part is g squared minus r squared. So simplify, here we have r squared equal to 2 times g squared minus r squared, so r squared is equal to 2 times g squared, 2 times r squared. Then we have r squared plus 2r squared, so that is 3r squared equal to 2g squared. Now isolate r squared, that is equal to 2/3 g squared. And r is equal to square root of 2/3 times g. And g is equal to 25. And then rounding our answer for r to 2 decimal places, that is 20.41 centimeters. Now that we have the radius and height of cylinder, we can find volume. So volume is equal to pi r squared times h. So that is pi times, where r was square root of 2/3 times 25. And then square times h was 2 times 25 divided by square root of 3. So I rounded to 2 decimal place, and volume is 37,787.49 centimeters cubed. So this is the answer for volume of cylinder. The height of an object moving vertically is given by s equal to -16 t squared plus 112 t plus 84. T is in seconds. Find the object's velocity at t equal to 5, its maximum height, and when it curves, and its velocity when s equal to 0. Recall that velocity is equal to s prime, and that is -32 times t plus 112. Now use t equal to 5 to find velocity. So this is negative 32 times 5 plus 112, and that is equal to negative 48 feet per second. The maximum height occurs when the object stops rising, and this is when velocity equal to 0. So set velocity equal to 0 and solve. And velocity is equal to negative 32 t plus 112. So t is equal to 3.5 seconds. Next step, the height of the object at 3.5 seconds is equal to negative 16 times 3.5 squared plus 112 times 3.5 plus 84. And the answer is 280 feet. To find velocity when s is equal to 0, first solve s of t equal to 0. So negative 16 t squared plus 112 t plus 84 equal to 0. Use quadratic formula. The solutions are negative 0.68 and 7.68. I rounded to 2 decimal place. The point is we cannot have negative answer 4 times, so our answer is 7.68 seconds. Next step, substitute t equal to 7.68 into the expression for velocity. So finding velocity when s equal to 0, that is negative 32 times 7.68 plus 112. And our answer for velocity is negative 133.76 feet per second.